So let's start with an ideal situation. Let's assume that you are hired as the operations manager in a company, and on y-axis we are going to show your inventory level, and on x-axis we are going to show time. So here is the time, here is the inventory position that you have. Okay, and let us assume that you have no inventory of that specific item we are talking about, and at time t you receive, let's say, 100 units of that product. And also let us assume that you have a demand that is constant, so every day and during the working hours you have a constant rate of selling that product. So your inventory level will go down, let's say every day. Let's say at the end of day 1, at T1, your inventory level will come here. At T2 it will go there, at T3 it will go there, and at T4 it will go there. And every day you are consuming 20 units, or you're selling 20 units of that product. So 20 units, 20 units, and so forth. So at T5 you will have no on-hand inventory, and if somebody comes to you to buy something, then you don't have anything to sell, or you don't have the product available. That means a cost of lost opportunity, and this is what we want to avoid as much as we can. Now, in an ideal world, let's say if you are running a business that your supplier is just next door, like a mechanic shop whose the tire supplier is just next door, if your inventory ends, then you will go and will buy another inventory, you will buy another amount of the same product, and let's assume that you buy the same amount. And if you buy the same amount, then the same story in this ideal world will be repeated. So you will consume that over 5 days, and then it will finish, because you can immediately get the product that you need right at the time that it reaches 0. So basically for you, there is no cost of lost opportunity. Actually, you probably don't need to buy 100 units. If that the world is that ideal for you, you can buy less amount and then do this more frequently. Let's say in an ideal world, you if the supplier is actually next door, what you can do is basically what is called zero inventory management. So at the beginning of every day you buy 20 units, you consume that. At the beginning of the next day you buy another 20 units, you consume that. And basically this way, you over the night you don't carry any inventory. But most of the people in the world, they don't have this luxury, and the supplier is not next door. If you put your order at this point, then what will happen to you? There is a time between that you put your purchase order till the time that the inventory arrives, and that we call the lead time. And then if that happens, then your next shipment will arrive after the lead time, and then your inventory will go up again and you have things to sell. But this is a really bad disaster. Let's say if the lead time is 2 days, so for 2 days or 2 units of time you don't have anything to sell. So what is the solution? We have to think of a way to fix this problem, and to fix it is that instead of waiting until the inventory level reaches to this point. We to reaches this point. Way before that, we put a purchase order. So for example, if I put a purchase order at T3, I'm sure that if the lead time is 2, it will arrive after 2 weeks, so exactly at T5, assuming that we are living in this world that the demand per unit of time is constant. Then if I order it at T3, then it will arrive at T5. A way that commonly is used to fix the problem is that we think of, okay, let's assume that the lead time is 2 days. Okay, so if lead time is 2 days, if I order at T4, I know that when I am at this level, the inventory level is at 20. And I have 1 week to sell this 20. But if I order when I have 20 units on hand, then when the order arrives 2 weeks later, I have run out of stock. So how about we order when the inventory on hand is already at 40? Okay, so I will ask my inventory manager, look, whenever your inventory reach to level 40 quantities on hand, put your purchase order. We know that it will take 2 days, the lead time of 2, for orders to arrive. Therefore, this point is called reorder point. Basically, this is the level at which we will put our order, even when we already have 40 units on hand, considering that the lead time is 2. To generalize our understanding, the reorder point is the lead time multiplied by the demand per unit of time. In other words, the order point in this example, the lead time was 2 days and the demand per unit of time was 20. Therefore, the reorder point is 40. Now let us see how we can find the reorder point if the world is not that ideal. And let's think of how is a world that is not ideal. Okay, again, we consider our inventory and time, and again, let's assume that at time t0, we get a quantity, let's say again 100, let's call it Q, and like before, this is time and this is inventory position. Okay. Now, if the world is not ideal, so our demand for our product after the shipment arrives will not be a constant rate of D equal to 20 as it was before. It is possible that at first we will have during the first week we have a demand of 20 units, so fine, this is what we will have at T1, but suddenly during T2 the demand may increase, so the slope of this line suddenly changes, and at T2 we may have fewer than, now maybe at this time we consume 25 units. So let's call it D1, D2, and then in the next period of time maybe the demand is also very fast. The demand is very high. Therefore at T3 we are much closer to the zero inventory. Now of course it is, so let's say it's also 25 at the time during the T3, and during the third period of time. And now it is possible that during the fourth period of time the demand may go down, and let's say we only sell 5 units. So this is D4, and then suddenly in the middle of the fifth period the demand goes very fast down, and we reach to 0 before T5. So compare this with the flat rate that we had before, which was 20 units per time, per unit of time per day, which would lead us to have to finish our inventory exactly at T5. That would give us a very certain way of reordering, and we decided that okay, whenever we reach to 40, whenever the inventory level reaches to 40, we will put a new purchase order. It will arrive in 2 days, which was the lead time. Everything was fine. But now, because the demand is not constant, when the demand goes higher than average, then there is a chance for us that we will have cost of lost opportunity during this period of time. What should we do? We need to, instead of 40, we have to put our purchase order a little sooner. So as the product is being consumed, if we put our purchase order when we are at, for example, let's say when the quantity is 50, we put our purchase order, then we have 50 units on hand, and it would take more than 2 days for the product to arrive. If you order at 50 and the demand is as average, then we we will have some extra, let's on average 10 units extra when we reach to T5, because we ordered sooner, the product will arrive sooner. So the product will arrive here. So the trick is that we will put the reorder point before we reach to 40. So let's say the reorder point in this case will be DL, which would give us 40 plus a little bit, and that a little bit would be our safety stock. Now the question is how much this safety stock should be. Maybe we have to put our reorder point at 80. Just if we put our order every time that we reach to 80, basically we have 80 units on hand, we buy another 100 units, so we have a lot of stock all the time. But having a very high level of safety stock will cause our inventory costs to go up. If the safety stock is too low, then if the demand during the wait time is more than a level, then there is a chance that we will have cost of lost opportunity. So to calculate the safety stock, it is obvious that the safety stock is needed because of the uncertainties of the demand. If demand wasn't varying, then the safety stock wouldn't be necessary. So we need to find out how much is the variation of this demand. If we see that the variation of demand is a lot, then we need a lot of safety stock. If we see that the variation of demand is not very much, then we will need a little bit of safety stock. Assume that you are hired in our institution. The first thing that you will do, you'll tell me that to design your reorder point, the word I know that it is not ideal. I cannot set it at DL. I need to calculate the safety stock. To know the safety stock, I have to know how much your demand varies. The first request that you will have from us when we hire you is that you'll say, okay, give me the demand of the past periods. You need a table that in it we have the time buckets and the demand that was observed during that time bucket in the past. So let's say time 1 we observed a demand of 21 units. At time 2 we observed a demand of 22 units. At time 3 a demand of 18. At time 4 a demand of 19, and so forth. And that if we look at all of these demands, you will realize that the average demand, which we call it D, is sum of these demands, D1 plus D2, all of the demands that we are observing in the past, divided by number of past observations that we have, which in this case the average demand would be 20. And to find out how much is the variation there, the best method of calculating the variation is using the variance. Variance of this data can be calculated using your calculator. So you type these numbers in your calculator and then you get a variance. So let's assume that you typed all of these days up to day 20, and we realize that the variance is 4. That means that the standard deviation of variations is 2. Now that we know the variation in each time domain, now we have to think of in how many days we are susceptible to this variation. When we are at this point or at this point, we have not put any purchase order yet, and if the demand goes faster or slower, we don't care at this point. If the demand goes faster, we will reach to the reorder point sooner, and then we will put the reorder point sooner. So if some speed up happens before we put our order, we don't care, because that's fine for us. What matters for us if that during the lead time, if the demand remains at 20 per units and we order at when we have 40 units on hand, that's the only thing that we care about. If before the reorder point, before we put a purchase order, the demand changes, it just makes us to make the order sooner. But once we put an order when we are at 40, the order is shipped to us, and now we have to wait 2 units of time for the products to arrive, and that is what matters for us. Therefore, the sensitivity that we have for calculation of the safety stock is limited to during the lead days. During the lead days, during the lead time, we are waiting for the products to arrive. Now, if the standard deviation of demand per unit of time is 2 units per day, you may think that the total variation during the 2 days that we are waiting, the variations that we are facing during the lead time, you may think it is the standard deviation of the first time plus the standard deviation of the second time. But that is not true, because these demands in these days are independent, and it is quite possible that on one day the variation would be positive, in another day the variation would be negative. It is possible that some days the variation in both of them is positive, like the demand is getting above average in both of them. It is possible that both of them are negative, but there is also possible that in one of the days it's positive and the other day is negative, and in those cases they cancel each other. So the change in demand is not the variations of the demand don't add up like this. They don't add up like vectors that are in the same direction. So if you have vector 1 and vector 2, the total vector would be vector 1 plus vector 2. In fact, the demands don't add up that way. The demands add up, the variations of the demand don't add up that day. Variations of the demand add up like independent vectors. Let's say, like when we have this is, let's assume that this is the variation of one demand and this is the variation of another demand independent of that one. So the total variation will be calculated like that, and you can say that if this is what we want, we know how to calculate. Have to find the variance. The total variance during the lead time is the variance during the first unit of time multiplied by plus the variance of the second unit of time, and we are waiting for L days. We have to add the variances of all of these days, and if we assume that the variations of demand is constant and it is 2 units per day, then therefore during the lead time we have L of these variances. Let's say if it is per unit of time, the variance is sigma t to the power of 2, then the total variance during the lead time will be calculated based on this formula, or you can say that the standard deviation during the lead time is the square root of the lead time multiplied by the standard deviation per unit of time. Now, in this specific example, if you want to calculate the variation during the standard deviation of the variations during the lead time will be square root of 2, because the lead time is 2 and the standard deviation of units per unit of time is 2, so it would be 2 square root of 2. Now you may say, why do we need this? We need this because now if you think of the possibilities that we will have cost of lost opportunity or stock outs, the most expected demand during the lead time would be expected value, or the mean demand during the lead time is DL, of course. But we know that it can vary, and we know that the standard deviation of these variations during the lead time is 2 square root of 2. Now this knowledge, this is the demand during the lead time. During waiting for lead time to end. Okay. Now, if we set our reorder point at DL, the problem is that there's 50% chance that the demand during the lead time will be less than it, 50% chance that it will be more than it. And if this 50%, that means the demand during the lead time is will become more than what we are expecting, then there is the cost of lost opportunity, the cost of lost sales. So basically there is 50% chance of cost of lost sales if we set our reorder point at DL. But if we set reorder point a little higher and we consider this the safety stock, then the chance that the stock out will happen beyond that level, if the average is DL, would be much less. So let's say if you want to be 95% sure that we will not have stockouts, then this area should be 95%. That means that we have to put our reorder point above DL this much, such that, so we have to find the Z that gives us the area of 0.95 under the normal curve, and then we would set our reorder point at this level, which is Z standard deviations to the right of the mean, and basically the reorder point with safety, instead of being DL, is DL plus Z standard deviations. Just that this is the sigma. Okay, if you go to the table, we will see that for Z equal to 164, it is 94950. For Z equal to 1.65, it is 95053. So it's a little bit more than 95%, and we want to be safe. So if we choose 165, then DL is 2 multiplied by 20 plus Z is 1.65, and 2 multiplied by 2 square root of 2. If we set our reorder point as this level, then we will be more than 95% confident that the stockout will not happen. And now, what are these values? So this would be 40, and this is this term here is our safety stock. So this equals 1.65 multiplied by 2 multiplied by square root of 2. 46669, 4.6669, and that means that we will ask our inventory manager to put a purchase order whenever we are at now this is 44.6. We cannot order a fraction of a product. So what should we do? Again, we want to be on the safe side, so we say whenever we reach to 45, put your purchase order. So this is, here we rounded up, here we rounded up, and here basically this is a roundup of what we need. So we'll say that if we put our reorder point at 45, we are at least 95% confident that the stockout will not happen, and reorder the safety stock is 5.